I started climbing when I was, I think, 7 years old. Very quickly, I loved the sport.
I brought a newspaper up to read it, and the headline was, "Rescuer Killed, 2 Boys Not Found."
My rehabilitation doctor told me that I definitely would not be able to return to rock and ice climbing. I was, of course, devastated. I came up with all these assortment of prosthetic limbs to penetrate an ice surface, to wedge into small rock fissures, to stand on rock edges the width of the dime. I began actually ascending rock faces that I could not have ascended before the accident with biological legs.
Now, after giving him back his legs, Hugh Hare, director of the biomechatronics group at MIT, is a strong advocate for advances in the technological interface between body and machine. Here, Hugh Hare discusses the ability for humans to overcome biological limitations through technology.
I realized that technology can heal, can rehabilitate. And in my own case, technology from time to time can augment human capability beyond what nature intended. I was able to climb at a more advanced level after my accident with artificial limbs than I was ever able to achieve before my accident with normal biological limbs.
Krishna Shenoy, a professor in neural prosthetics at Stanford University, will explain how neural signals are relayed to machines in brain-machine interface.
Shown here is the potential solution to potentially read out neural signals directly from the brain and use those signals after some interpretation or decrypting, if you will, to drive prosthetic arms or computer cursors on a screen. Now, if the spinal cord is injured, for example, what we propose to do is to tap into the electrical signals associated with individual neurons, interpret those neural signals with mathematical algorithms as run on custom-designed chip, and then deliver those computer signals either to guide a computer cursor on a screen or onto a robotic arm.
Miguel Nicolelis, a pioneer in brain-machine interface, discusses the possibility of curing paralysis through innovations in this technology.
If there is a severe lesion to one part of the brain, like the spinal cord, the messages that we produce in our brains about motion, about moving, about exploring the world, cannot reach our muscles, can no longer command our body to move at will. Well, although these lesions occur, our brains, for the rest of our lives, continue to produce the messages, continue to dream about motion. Our idea is to use brain-machine interface to actually restore motion to these patients, to use the electrical activity decoded with computational models, and then use this to command a new body, a body that these patients would wear, a robotic device, an exoskeleton that these patients would wear like they wear their own bodies, and then move through the world.
However, many are concerned with the ethical implications of this new technology, especially as it relates to prosthetics that provide a competitive advantage. For example, runner Oscar Pistorius, a double-legged amputee, was banned from the 2008 Summer Olympics because of his prosthetics.
They call him the Blade Runner, the world's fastest man on no legs. His dream has always been the Olympics, but his biggest opponent hasn't been other runners.
Gear cheetahs give you an unfair advantage?
Not at all. Not at all. If they did, I would not be running.
But the body that governs track and field disagreed, saying his prosthetics had more spring than human legs, and banned him from competition. When I met Oscar last year, he almost couldn't believe it.
I can't see that prosthetic can be seen as an advantage. It's such a weird concept to just think about.
Science fiction movies bring up some of the possible transhumanism implications of brain-machine interface. What if prosthetics became so advanced that those who could afford them would attain them for the sole purpose of enhancement, leading to two classes of humans, those with machines and those without?
Ladies and gentlemen, we are now seeing the beginnings of another stage of human evolution.
The truth is that mutants are very real, and they are among us. We must know who they are, and above all, what they can do.
And what if, instead of controlling the prosthetics with our brains, the prosthetics could advance and control us?
I miss the good old days.
What good old days?
When people were killed by other people.
My robots don't kill people.
That thing threw somebody out of a window. Is that registering with you?
Brain-machine interface's ability to artificially provide communication and movement to disabled individuals makes it worth widespread attention. These benefits outweigh the possible risks associated with the technology.